Hello and welcome back. Let's continue our discussion on logarithmic functions. So let's continue with question 32. What are the values of x in this inequality? Again, when we have an inequality with some functions on the left side and right side, the first thing that we do is make sure that we have the valid domain for x, right? The inputs are valid. And right now everything is fine, so there is no limitation on the x. X could be anything, positive, zero, negative number, okay? But the base is 1 over 2, which is a number is between 0 and 1. I always prefer to make it a number greater than 2, so I write 1 over 2 equal to 2 to the negative 1 power, and then this inequality becomes 2 to the negative x squared minus 2 is greater than 2 to the negative x. And now because 2 is greater than 1, these exponential functions are monotonically increasing, therefore the inequality goes on the powers as well. So minus x squared minus 2 is greater than minus x, therefore x squared minus 2 is less than x. I multiplied both sides by negative 1, okay? And therefore x squared minus x minus 2 is less than 0. If I factorize this quadratic form, which we will study the quadratic forms in more details, is that it becomes x minus 2, x plus 1, x minus 2, x minus 2, x plus 1 is less than 0, okay? And this quadratic form has two roots, is negative 1 and plus 2. At infinity, at x infinity goes up, goes to infinity, therefore the shape should be something like this. And if we want it to be negative, x should be between negative 1 and positive 2, okay? Question 33. What is the solution for 10 to the x squared minus 2x less than and equal to the 2 raised to some weird power, 2 minus x over log 2, okay? This is interesting, and the reason is that the bases are different. So how do we solve this? Now, first of all, again, here the log is given, we have log 2, right? And we have to assume that it's the meaning of this, because the base is not mentioned, we have to assume that it's log 2 in base 10, okay? Let's take a log 10, log in base 10 of both sides. Then log in base 10 is monotonically increasing, therefore the inequality stays the same. So x squared minus 2 is less than or equal log of right side, which is 2 minus x divided by log of 2 in base 10 times log of 2 in base 10, okay? And the logs cancel out, so x minus 2 x squared minus 2 is less than or equal to 2 minus x squared plus x minus 4 is less than equal to 0, okay? Sorry, we made a mistake. X squared minus 2x less than or equal 2 minus x. Therefore, the inequality, the final inequality becomes x squared minus x minus 2 is less than or equal to 0. And this is exactly what we just solved. So it has two roots, plus 2, negative 1, and x should be between negative 1 and plus 2. Now what happens if it's Now you see right now what we're getting is that none of the four solutions, none of the four choices satisfy this, right? In order to see which choice is actually the correct choice, we have to think about what happens if x is -1 and x is 2. So if x is plus 2, then we get 10 to the 0 less than equal 2 to the 0, which is true. If x is -1, we get 10 to the 3 is less than or equal to 3 over log of 2 in base 10, which is 10 to the 3. So yeah, I think the equalities have been missed, but the correct solution is number 1. Alright, so question 34. What is the result of the integer part? Again, a square bracket means integer part of log of 157.1 in base 10 plus the integer part of log of 1.123 in base 10. Okay, again, base 10 is greater than 1, so we know that log of any number in base 10 is monotonically increasing function. Okay, so 157.1 is between 100, which is 10 to the 2, and 1000, 10 to the 3. So log of 10, 157.1 is between 2 and 3. Therefore, the integer part of the first term is 2. And log of 0.123 in base 10. What is this? So 0.123 is greater than 0.1, right? 10 to the -1, which is 0.1, and is less than 1, which is 10 to the 0. So if take the log 10, 1, 2, 3, between -1 and 0, and the integer part becomes the smaller number. So the second one becomes -1. So the result is 2 plus -1 is equal to 1. Okay? Now we can generalize this exercise, and I think it's a good exercise to do. If you've done the previous question, it's time to reveal the two relations. Log in base 10 of some number with n decimal digits, and then the decimal point and other terms. The integer part, remember the square bracket is integer part. And assuming that this number is positive, is n minus 1. Why? Because any number which has n decimal points and some digits after the decimal point, right? We're going to assume that a1, the leading term, is not 0, right? It's greater than 0. It could be 1, 2, 3, up to 9. So if this is n term, this means this is greater than 10 to the n minus 1, less than 10 to the n. Just for example, 157 that we discussed. 157.1, we had n equals 3, right? And we said that this is greater than 10 to the 2, which one, n minus 1, and 10 to the 3, which is 10 to the n. And if you want to know why, the maximum number that this can be is that each AI digit becomes 9, 999.99999, right? This is n9, so definitely less than 10 to the n, greater than 10 to the n minus 1, okay? And if we don't have any decimal digit and all of the digits are after the decimal point, it's just -1, because this number is always this number, point a1, a2, etc., assuming that it's positive, it's always greater than 0.1, because we're assuming that a1, the leading digit, is not 0, so it could be 1, 2, 3, etc. Obviously it's always less than 1. So if you take the log 10, we end up with -1 log 10 of this between 0, and the integer part is always -1. Okay. All right, this concludes our discussion on the logarithmic function.